Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us discuss today's session. What is the overview of today's session is. In the previous session, we have already discussed about what is a graph traversal, and then we come across two different types of graph traversals. One is BFS and another one is DFS. And we have seen one example how the BFS traversal is going to work, and we have solved one example also. Once you can refer the previous video for understanding this implementation of BFS. Okay, let us see the implementation part of this BFS. I will be showing you the execution part also. Please once listen for the program, how this program we are going to write and how we are going to execute it. Okay, and this is the program where we are going to implement this by using BFS with first search, right? And what is the data structure here? We are going to use this queue, and we know that as usual we required a header file stdio.h and the size to be defined. Here I am taking the size as 5. Okay, now we require a queue here. That's why we are taking the queue as size 5. And based on this, you will be knowing that the size of queue will be 5, and we can store up to 5 vertices into that queue. And the visited vertex for visiting, after visiting we are going to place that this is visited, right? A particular vertex is visited. For that particular purpose, we are going to use this array called visited of. That depends on again the size of your queue, right? And this A of 5 is representing the array, that is a 2-dimensional array. We are representing the graph in terms of an adjacency matrix. Because of that, we are going to use 2-dimensional array representation. And these are few variables where we are going to use in the program, and we all know that front, rear, these are the two variables where we are going to use in the queue data structure, right? By using rear end we are going to insert, and from using front end we are going to delete. For that purpose we are going to take these two variables, and front equal to -1 and rear equal to -1 represents your queue is empty. Okay, this is the way how we are going to represent 1, 2, 3, 4, 5, and front is pointing to -1, rear is pointing to -1, and this is your queue representation. Okay, now you know that by using this function we are going to insert the element into the queue. By using rear increment we are going to insert, and if you want to delete, by using front we are going to delete. Here this function is going to return value if it is deleting, and is queue is empty queue. That means if front and rear both reaches to the same position, in that particular case the queue becomes empty. That means if it is empty, then it is going to return the value 1 to the function where you have been called. If it is not equal, then it is going to return the value to 0, right? These are the three functions where we are going to use. Now you need to understand this concept mainly. This one we will discuss how it is going to work, and before going to work on that BFS, let us see what we are going to do in the main function, then we will go for that. Okay, and here first we need to enter the number of vertices. Consider this is a graph with 3 vertices. Okay, and the adjacency matrix we need to take. Consider the adjacency matrix for this graph is like this. Consider here everything will be represented in terms of 1s and 0s, so that I am going to give my graph numbering is 1, 2, 3. 1, 2, 3 are the numbers. That means the vertices are 1, 2, 3. If you want to represent another graph like a square, in that case you can use the vertices as 4. You can take number of vertices as 4, so that you can get that particular adjacency matrix. Right. This is a matrix. Now based on this is an undirected graph. Based on this, represent what is the adjacency matrix. For this we are going to write this logic, where you are going to read the array elements based on the graph and how the edges that was connected, right? According to that we need to read this adjacency matrix. Now for 1, 1 you don't have any self, that is 0, and for 1, 2 you have an edge, that is 1. For 2, 3 you have edge 1. For 2, 1 you have an edge 1. For 2, 2 you don't have any self loop, that is 0. For 2, 3 you have edge is 1. And 3, 1 you have an edge 1. For 3, 2 you have an edge 1. For 3, 3 you don't have an edge. This is an adjacency matrix where we are going to read. This is for the number of vertices with 3. Okay. Now, at the same time, what we are going to do is, for knowing whether we have visited that particular vertex or not, we are going to take another array. At this declaration itself, we have given this, right? Now, what this loop is going to do? This is the for loop where it is going to take the size of same 5, and this is your visited vertex name V of. Now, I starts from 1 onwards. Here everything we are going to take it from 1 onwards. Okay, let me take it from 1, 2, 3, 4, 5. Instead of taking 0, I have started from 1. Right? If I equal to 1, I less than or equal to n. I becomes 1, 1 less than or equal to 3. If this condition is true, we are going to initialize I, visited of I with 0. Yes. Here at the starting, we are going to place everything with 0. 3 vertices, 3 places will be filled with zeros. Until this condition fills, this visited vertex values will be filled with 0. Now, actual logic is going to start. This is the number of vertices where we are going to read. This one will be reading the adjacency matrix based on your graph, and this will be taking that whether you have visited a particular vertex or not, that we are going to present it here. Initially, we are going to make it as 0, and then if it is visited, we are converting it to 1. Okay. Now, I am going to start taking my vertex from 1 onwards, that is BFS of 1, the starting vertex which I am selecting it as 1. Now, come to the actual logic what we are going to do. Now, whatever you have taken, that will be passed into V. Now, you are going to call the function called insert. We have taken a queue, right? We have taken a queue with size 5, and this is the name of your queue. The first value which it is going to be passed into queue is based on the function which you are going to call, this one, into V by incrementing the rear value. Initially friend equal to -1 and rear equal to -1. Now, rear will be incremented and we are going to insert the value 1 into Q by taking this statement. Now, it is going to check is empty, not is empty. Here you have an element so that it is not an empty. Now, what we are going to do? We are going to perform the deletion of a Q. That means 1 is going to be deleted from here. Into V, we are going to store the 1 value. Now, we are going to print also, print that 1 value. This is for printing, print 1 value. Now, visited of V equal to 1. Now, if I have visited that particular vertex, I am going to place that with 1. Now, we have one more array which we have taken is visited vertex as the same size of Q. Now, previously it was 0, now we are going to place with 1. That is these 3 statements telling about. Now, start checking for I equal to 1, I less than or equal to n, and this has to be repeated. This process has to be repeated. Now, this is the vertex where you can have. This is the adjacency matrix we have 1, 2, 3, 1, 2, 3. Here you have 0, 1, 1, 1, 0, 1, and here you have 1, 1, 0. This is the matrix where we have taken, right, based on the graph. Now, I starts from 1 onwards, I equal to 1, 1 less than or equal to 3, right, so that it will be entering into the loop A of V. V is nothing but the 1 value, and I value is also 1 equal to 1. And visited of I is nothing but visited of 1 equal to 0. This is the condition it is going to check, right. A of 1, 1 value, A of 1, 1 value is nothing but 0. 0 equal to 0 equal to 1? No. And visited of 1 value is 1. 1 equal to 0? No. It will not enter into the if block. Now the for loop will be repeated. Now the for loop iterates because the condition is not failed. Now I becomes 2 less than or equal to 3. Now again the condition is true. Now what is going to be changed here? V is 1 itself, 1 2 equal to 1, and V of I is nothing but 2 equal to 0. Yes, A of 1 2 value is 1 equal to 1, and V of 2 value is nothing but 0 equal to 0. Here this condition is true, so that it will be entering into the Q, insert Q of I. When you are going to call this function insert Q of I, now I value is 2, that will be inserted into the Q by incrementing the rear value. Rear will be incremented, we are going to insert 2 here. At the same time, we are going to place visited of I is nothing but visited of 2 equal to 1. That means we are going to place this one as 1. That means we have visited that second vertex and we are going to place that into the Q. Q we have placed, right? This was done. Now this loop will be repeated for the third time. This is not ended, right? Still the condition is not fair. It is iterating. Now I becomes 3. 3 less than or equal to 3. Condition true again. A of V is 1 only and I is 3. I is 3 equal to 1 and visited of 3 equal to 0. Now you see A of 1 3 is 1. Yes, again the condition is true. And B of 3 is also 0 equal to 0. Condition true again. Right? In this way you are going to check. Now it is going to check insert of I. Now it is going to be inserted with 3 and visited of 3 also becomes 1. Now we are going to insert 3. Right? Now what happens after terminating from this loop? Now this will be repeated and checking is empty of Q, not empty of Q. No, it is not empty. Now what we need to do? We need to delete it. This one is already deleted, right? This one is already deleted. Now we need to delete the next element. This 2 is going to be deleted. Now V becomes 2 and we are going to print the 2 value. Right? Now you can able to trace out in the same way how we have worked for the first row. First row we have completed. In the same way we need to check it for the second row as well as for the third. Now if we have tried this, if you can try the same logic for the remaining 2 rows, already we have visited almost 3 vertices which is already placed in the queue. All are going to be removed at the end of your implementation. The queue becomes empty. These are the values that will be printed, that is 1 2 3 will be printed. Okay, you can try tracing the remaining 2 cases. You can check it out, right? You can try to solve this remaining 2 cases, and based on this, what is the output you are going to get, right? What is the output you are going to get? Let us see how we are going to execute this program. Open our online C compiler GDB. In this, I have done the program already. Let us see how this is going to work. This is your BFS program. Run it. Run once. Now it is asking for the number of vertices. I am giving it as 3. Now asking for the adjacency matrix. Let take the same example which we have taken. That is 1 1 you have is 0 0 1 as per the graph I am giving, right? And for 2 1 you have an edge. For 2 2 you don't have an edge, and for 2 3 you have an edge. Edge means edge is there means 1, and for 3 1 you have an edge. For 3 2 you have an edge, and for 3 3 you don't have any edge. If I am going to give like this, it will be printing 1 2 3. These are the vertices which it has been visited. Okay, I hope you understand this concept. Okay, in this what are the things we have discussed? We have seen about the graph traversal implementation of BFS. Still any doubts? If you have, please do comment in the comment section. Thank you.